Hello, and welcome to all. Hope everybody doing great. Hope you have completed all previous my YouTube videos, what I have already shared with you related to electrical systems in how you implement in the project in various aspects. We have already covered many of the things. If you have not yet completed, please go back and watch all the videos, and definitely you will get some value. And you have any comments, you have any doubts in your mind, just share with me in the comment box. And what I have shared with you till now in few of the videos the last couple of weeks, that is related to how you learn from AI tools. The same thing I want to continue today also. In today's session, I will share with you a case study, you can say, case study in terms of what type of problems we are facing in the project. So I just mention one problem and ask ChatGPT to find out the solution and give more details about this problem. Okay, let's see what it will come. So before just starting, I just want to tell you another thing that shortly I will share some of the new topics related to project management, then managerial skills, and we are going to start a sessions from mostly from the next year January, where I will guide you based on my experience, last 23 years of experience in the construction industry and the MEP domain, how you go to the next level very quickly. So there is many strategies, hacks, and guided structured systems I'll share with you. So stay tuned with me, and definitely you will get values every day from the YouTube video also. So let's start. I just want to share my screen. So here randomly I am going to ask a question. Let's see. So I have written that we have installed a 1000 kVA dry type transformer in our commercial building project. We face no, we are getting humming sound from the transformer after commissioning. Please help me to understand the reason for the humming sound and provide a solution to rectify. Let's see. Whatever just came in my mind, I just put it there. So I just read out what is mentioned by the ChatGPT, right? A little hum is normal in a dry type transformer, but a loud or new hum means something is vibrating more it should, either inside the core or windings or in how it's mounted. And sometimes supply harmonics or load conditions make it worse. So let's break it down this way. Why do dry type transformer hum? So these are the reasons has been mentioned, is that magnetostrictions of the core. When the magnetic flux in the core rises and falls, there is 50 hertz to actual twice per cycle equal to 100 hertz mechanical vibration. The laminations want to expand or contract slightly. That creates a bass hum. This is inherent. Now, vibration getting transmitted to structure, even a normal core hum can sound loud if the transformer is hard coupled to a concrete plinth or steel frame without proper vibration isolation. The structure amplifies it like a speaker. So loose parts, core clamping bolts not tightened properly, loose LV or HV coil supports, loose enclosure panel stores, loose busbar support. So any looseness equal to more rattle on top of the base. 100 hertz hum. Supply related issue, electrical causes, over voltage, higher flux, more magnetostrictions, more hum, unbalanced three-phase voltage, uneven magnetic force, vibration, harmonics from VFD, data loads, LED drivers, sometimes with higher pitched components, Locations and acoustics. A transformer in a closed room with reflective walls, bare concrete will sound louder than the same transformer in a treated room. Now, what to check first? There is a practical checklist at the site level. Confirm its operation at rated voltage. So measure line-to-line voltage on HV site or LV if that supply site for cast resin. If voltage is greater than 2 to 3% above nameplate, humming will increase. If the tap is wrong, correct tap to bring flux down. Check the load condition. Is the hum present even on no load? Yes. More likely core or mounting issue. No, or increase a lot with load. Check harmonics, unbalanced, loose windings. Check phase current balance. There is greater than 10% unbalance. It can cause extra vibration. And physical inspections with shutdown if needed. After shutdown, check core clamping bolts and yoke bolts. Are they fully tightened as per OEM? Check HV or LV terminal connections. Check panel door gaskets and covers. Check cooling fans if fitted. Then mounting and the foundation. Is the transformer placed directly on RCC or steel base without anti-vibration pads? Are all 4 or 6 mounting points levels or it rocking slightly? A rocking transformer will hum louder surrounding equipment. Sometimes the hum you hear is actually the LV panel or bus duct connected to it resonating. Push on the panel or cable riser and see if noise changes. The typical root causes in commercial building. From what you described, 1000 kVA dry type, post-commissioning hum, most common are normal core hum getting amplified because it's bolted directly to the plinth. 1 or 2 loose enclosure or panel after transport or installation. Slight overvoltage from utility or TG synchronization setting. Harmonics reach load, that is commercial building, lift, HU, VFD, FCU, lighting, and drivers. Number 4 is the corrective actions and solutions. What are the solutions has been given here? That is, number 1 is the mechanical or mounting fixes. Provide vibration isolation. So as earlier also it has been explained, insert neoprene or rubber or cork rubber anti-vibration pads under the transformer base channels. As per your project, it may different specifications has been mentioned. Just check there. If already grouted, put isolation pads between transformer and the base frame. Make sure all boards are tight but not over tightened to short circuit the isolation. Then stiffen or damp the enclosure. Tighten all the enclosure screw, door, latches, and busbar support clamps. Where a sheets signing, add a small damping strip. Sometimes just adding one L angle support. So decouple connected item. Flexible connections to LV panel or bus duct to avoid transmitting vibration. Check the cable thread touching the transformer body. So, and these are the mechanical fixes. Electrical fixes: set correct tap need to change. Check if you measured high voltage, shift to the lower tap as per manufacturer. This often immediately reduce hum because magnetic flux drops. Check load balance and the harmonics. So measure the THDV or THDVI. If you have a PQ analyzer, if high, consider detuned harmonics filters, K-rated transformer for future loads, and separating heavy VFD loads to another transformer. Even without an analyzer, if you notice hum increases sharply when VFD heavy loads run, it's a harmonics issue. Check earthing. Poor or multiple hard bonds at vibrating points can create buzz spots. Ensure earthing is as per OEM, not over tightened on the panels, on thin panels. And room and architectural fixes: if sound is still high, Add acoustic panel on walls or ceiling. Avoid placing it in a small, highly reverberant room next to the occupied space. Seal door gaps to stop structure-borne sound traveling to others. Now, when it's normal, you should investigate further and call your OEM if you notice hum suddenly increased compared to a day of commissioning. The hum changes with temperature. There is a metallic knocking, rattling, not steady 100 Hz hum. Transformer has not spots or unusual vibration on only one side. Insulation test. So whenever you found this kind of problem, immediately better to call OEM because it is under warranty. Your system will be under warranty. So it is not advisable to touch the transformer by yourself because there will be a warranty clause by violation is there. So what I recommended you do now, step by step for your site. Number one, measure and record HVLV voltage, load current in all three phases. If you have all the equipments, you can do that by yourself, or you can call OEM to execute all those things. Run transformer at no load, press test, check back, check base, correct tap, document with a short video, plus DB reading. So there is DB reading, decibel reading, phone app, and send to OEM. They can tell you if it is within their acceptable noise level, typically around 50 to 65 decibel at around 1 meter for the size for this size, but depends on make and enclosure. So that way, at least you can understand what are the problems. You can why the reason of the problem you can find out by asking this question from the AI tool, and you understand also what type of solutions are there. Okay, so this is the basic and the fundamental of how to find a solution for a problem. Just I have to stop this. So my motto is to understand you that anything you will get from the technology, but only thing is that you need to ask the right question. So based on your experience, if you're working in the construction industry and if you have certain experience, and definitely you will facing some new challenges in the project. And all projects are different. There is no comparison between two projects. Suppose if you think you have a good experience, more than 10 years, and you know everything about the project because you have already gone through various challenges, and you will not any challenges in the next project. It will not happen, never happen. Some new things will come. So like our life also, there is a ups and downs are there. So it is the same kind of thing for everywhere. Okay. So accordingly, how to handle pressure, how to handle this kind of situations, that immediately if you want any solution, then you can get solution from the AI tools also. So it develop into develop by that way. So okay, hope you understand my point, and if you're getting value, just share your comments, and still if you have not subscribed my channel, please subscribe so that you will get new idea, new videos every day, almost every day, because normally I'm uploading the video every alternate day in the YouTube channel. So God bless you. Thank you. Bye.